Hey, thanks for joining us in Big Bear Math Country here tonight. And I'll tell you what, there may not be a more universal topic that every student has to tackle at some point in their math career than graphing linear functions. So I'm really excited to share with you a couple of tricks that I think are going to make that process really simple, really clear cut. And exactly what does a linear function look like when we graph it? And I bet you've probably predicted this. A linear equation simply makes a straight line. And what's really cool about that is the root word of linear is line. So it all kind of pairs together really nice. Now, I like to think that there are three really cool methods for graphing a straight line. We're going to cover two out of the three in tonight's video. We're going to talk about making a table of values and how to go about that. We're also going to introduce you to the process of finding the x and y-intercept really quick and easy. And then maybe the most popular one of all is the slope-intercept form that we'll cover in a later video. So just check out the playlist on our channel, and you'll see that video pop up here shortly. And that's another great way to graph these functions. We're going to jump right in. I don't have any real fancy definitions or crazy math lingo for you tonight. We're just going to jump right in. So talking about if we're going to use a table of values, here's what's really cool. Let's call these your input values. And let's call these your output values, okay? And if you recall from our previous video, that f of x is really just a fancy way of saying y. So, y equals 2x plus 3 is the same function. Now, you have the freedom to pick any input values you want. And I'm going to pick what I think are the three easiest, simplest ones. I'm going to go 0, 1, and 2. Now, you don't have to pick the same three that I picked. You have the freedom to pick any three numbers you want. I just think that those are the three easiest to calculate. All right, so again, if I was to substitute a 0 for this x right up here, it's going to become 2 times 0 plus 3, which makes 3. And how about what if I replaced that x with a 1? And so I did 2 times 1 and then added 3 to make 5. Whoopsie daisy, that's supposed to be a 5. And then again, what if I substituted a 2 for that x? So it's 2 times 2 plus 3 makes 7. And I'm going to try to graph those points. All right, we enlarge this graph just a smidge. So 0, 3 is going to put me right here. And then 1, 5 is going to put me right here. 2, 7 is going to put me right here. And let's see if I can use this tool here to draw a really nice line. Oh, Nelly. Oh, that's a box. Yeah, that's going to be a problem. Oh, dear. All right, this is going to give you guys something good to laugh at home here. Let's see. We're getting close. We kind of go through all 3 points there. That's not too bad. But basically, you just want to try to use a straight edge if you have one handy. Grab a ruler or some type of substitute nearby and draw the straightest line you can. And if those 3 points don't give you enough confidence, remember my table of values could be stretched out and enlarged. I could have said, what if x was -5? What's the y value? What about -1? What's the y value? What about +7? What's the y value? I could have made that table as big as I wanted to. And I'm going to tell you, no matter how high you go in your math career, how many math courses you take, there's going to be times where you always come back to this idea of making a table of value to help give you an idea of what some crazy function might look like. All right, moving forward, let's jump into this next example. Let's move my picture over here. All right. Okay, so this function's a little bit scarier looking just because of the coefficient on that x. And again, if you want to, you could rewrite this as y equals 1/2 of x minus 4. And everything we do is going to be about replacing this x. We're going to plug a number in place of that x. Now, you could go 0, 1, 2 again. Now, I'm going to show you a little ninja trick here. I'm going to go 0, 2, and 4 for my x's. Now, why did I think 0, 2, and 4 were going to be easier than 0, 1, and 2? Well, what I'm anticipating is that these numbers that I substitute for x are going to have to get multiplied by 1/2. So I wanted to pick even numbers for x to make the nicest, cleanest answers possible. Okay, so let's say if I substitute a 0 for this x right here, 1/2 multiplied by 0 minus 4 makes -4. Substituting a 2 for that x right here, 1/2 times 2 makes 1, and 1 minus 4 makes -3. How about we substitute a 4? 1/2 times 4 makes 2, 2 minus 4 makes -2. Let's go ahead and plot those points the best that we can. 2, -3, 4, -2. All right, all right. We're getting there. We're getting there. Let's try drawing. All right, we get ourselves a real nice line, and our equation is going to look like that. Now, technically, we would we want to indicate, maybe use some arrows on the end of that line to indicate that that line extends infinitely in both directions, both down and to the left and up and to the right. Every single point that that graph passes through is considered a solution, and in theory, there's an infinite number of points, and that's why we'd say that linear equation has an infinite number of solutions. Now that's method number 1 if you're keeping track. We said there's 3 really cool methods, 2 of which we're going to cover in today's video. That's method number 1, making a table of values. So the question begs, well, how many points do we really need to graph a line? Technically, you only need 2 points to graph a line. Anything beyond that is just kind of extra, information that kind of helps build our confidence. But the 2 that are the most important and could be the most helpful are what we call the point where it crosses the x-axis and the point where it crosses the y-axis. Those are really, really special points, and those are called your x and y intercepts. Now, this is worth putting in that notebook. To find your x-intercept, we're going to let y equals 0. So that's maybe a little counterintuitive because it's the x-intercept, but we're letting y equal 0. Well, then the script just gets flipped when you want the y-intercept. So if you want the y-intercept, we're going to let x equal 0. Don't worry, I'll remind you of that as we go through this next example. So here's how I like to organize my thoughts. We've got this equation, 3x minus y equals 6, and you'll notice right away that this equation is not written in the form that we were accustomed to in those previous examples. In other words, the y is not solved for. And that makes this method all the more attractive because of that. Because I'm not even going to solve for y. Okay, to me, it would be a waste of effort or energy based on all I have to do is find the x and y intercepts. So what I'm going to do is I'm going to remind myself that if I want the x-intercept, I'm going to let y equal 0. So now I've got 3x minus 0 equals 6. 3x equals 6, or in other words, x equals 2. So 2 comma 0 is a point that the graph has to pass through right there. All right, let's flip the script. If you want the y-intercept, we're going to let x equal 0. Substituting that, we'll get 3 times 0 minus y equals 6. 0, negative y equals 6, or in other words, y equals -6. So 0 comma -6 is the second point that the graph passes through. And now all I've got to do is try to connect those bears the best that I can. Oh boy. Kind of close enough, maybe, hopefully. All right, so here is this graph that I've got. Now, if I would have used the table of values like I did in the previous 2 examples, I'd get the same end result. We'd have the same line when we're all said and done. But to me, this idea of just substituting a 0 for y and then substituting a 0 for x is a fantastic method, especially if the equation is not solved for y. So, ladies and gentlemen, hope you got some great notes that are going to continue to build confidence. And if you found something helpful here, I'd really appreciate it if you hit subscribe at the bottom, hit the like button, and share this with your very best friends. All right, have a great night.